This is Rimrock Lake west of Yakima on the way up to White Pass. And there's all sorts of geology here, most of it cascade volcanoes, ghost volcanoes and the very young Titan andesite lava, but that's not our story today. Instead, we're going back more than 100 million years ago and finding some rocks that are from the earliest days of building Washington piece by piece. The Rimrock Inlier, Bob Miller's 1989 Rimrock Inlier paper. Let's look at some rocks and inventory yet another window into our exotic terrain past. Thanks for joining us. Let's get started. Yeah, there's some decent exposure here, much better than up at that Menashtash Inlier that we were desperate for rocks, weren't we? Got some power lines for you. Let's grab the old hammer. I couldn't find this hammer the other day, so found it. Thanks to the Thomas family for the gift. And let's give you a decent shot. I got no idea what we're looking at here, but yeah, let me just zoom back here. So, you're looking north right now to Rimrock Lake, and let's look at these rocks. I don't think I want to scramble all the way up there for a number of reasons, but we should get ourselves on the outcrop, don't you think? So I'll narrate my thoughts just as well as I guess you can talk out loud to yourself in your quiet room. Kind of greenish, dark, complicated. Kind of a strange, kind of a pillowy look. I don't want to get too locked into that thought, but do you see what I mean? That we kind of have these lumps in bedrock form. That's kind of interesting. Super quiet here this morning. It's wonderful. All right. Well, is there an easy spot to get up? He asks himself as he slips down the talus slope. Let's try that. There's a couple quartz veins right there. I can't tell if this is surface or not, but there's some interesting kind of inclusions here. Spread eagle. Oh boy. They keep slipping down the hill. All right. Kind of dead sound and stuff. Oh, here we go. All right, so this is kind of half what I expected up at Quartz Mountain, to be honest with you. I expected actual quartz veins and huge quartz nodules, and we just didn't have the exposure to see that. It's kind of dead sounding stuff here. All right, let's try this. Come on. Come on. Well, it doesn't look like cascade lava now, does it? Green, kind of waxy. The thing that jumps out at me initially is looks like we got way more quartz veins through this stuff than we have at some of our other Mesozoic inliers. We'll keep it rolling. Why not? Let's just keep looking here. Oh yeah. Okay. this is, you know, little quartz veins all through here. You know, that's not the main story. If you're a metamorphic geologist, you're like, what's this guy screwing around with it? Oh boy. Oh. Let's keep going on this one. Okay, I like it. I like it that we have some good exposure. Now, this looks pretty greenish to me. Now, I looked carefully at a map. You know what? Let's go over and look at that map. I got the old colored pencils out this morning before I left the house. And I looked at the units that Bob Miller had broken out from this Mesozoic window. We're looking at this rare window of Mesozoic basement where most of it is covered by younger Cascade lavas. Let's keep it rolling. Ignore the trash. Ignore the cow pies. Why are there cow pies here? Traffic starting to pick up. Not great, whatever. Yeah, let me try this. Put my hammer on the paper so they don't fly away. Grab these two things. I'll just show you this quick. This is the paper we're studying today. Bob Miller, 1989. And I am mostly using this today. You know, it's more than 30 years old. I don't know how out of date we are, but I'm sure that the basics of the rock ID and the basics of the mapping have not changed, so I think it's worth showing. Let's use the hood of the car here. All right, get out of my own shadow. Is this too much glare? Maybe we're okay. So, Ellensburg, Yakima, US Highway 12, up to the Y. Come through all these these are Columbia River basalt lavas, some Cascade lavas. We don't care about those today. And look at this. There's Rainier from last time. Ignore the Rainier, I know that's hard. Ignore all this orange, I know that's hard. Ignore all this brown. That's one of our biggest skills here when looking at exotic terrain basement rock. We've got to just ignore all this cover, all this stuff that's sitting on top. It's not doing us any favors. And that's why these windows into the Mesozoic basement are rare. So, Cle Elum, Washington. So do you remember the Hicks Butte episode? Looking at the gneiss and the magmas there. Last time when we were looking at an inlier or a window, it was here. That's the Quartz Mountain kind of Hereford Meadows business. But then the only other place on this entire map and the southernmost outpost of a direct window into the Mesozoic basement is all this green. It's a pretty big window compared to the Menashtash and the Easton windows. This is a biggie. And I don't know how much I'm going to travel around today, but here is Rimrock Lake, and we are here with this green stuff here. So we're looking at a little bit of the green on the map, but you can see, can't you, that we are going over to Clear Lake. We're going up the North Fork of the Tieton River. This is the South Fork of the Tieton. Yeah. So just to give you a sense, Yakima to Mount Rainier, and this is the kind of general idea of how much of the Mesozoic bedrock we have. The Rimrock Inlier, you're looking at it. Now let's get something a little bit more reasonable to look at. So here's where I broke out the colored pencils this morning, and this is from Bob Miller's 1989 paper. So here's Rimrock Lake, the white thing. And so out of all that green you saw, out of all the green you see here, and now here's Bob saying, well, it's not all the same stuff. Let's look carefully at the mostly metamorphic but some igneous rocks in the Rimrock Inlier. And let me get you oriented first of all. So Rimrock Lake, Burnt Mountain, that's where I was filming with the Cache Prairie episode, if you recall, where my mic cut out. Here's White Pass. So the bedrock right at White Pass is not Cascade lavas, but the bedrock is part of the Mesozoic basement rock. Surprise to me, maybe to you too. So I've got a bunch of blue, light blue, and dark blue. I've got some green, I've got some brown, and I've got some red. Those are my colors. They just happened to be the colored pencils I had on my desk in the front porch this morning. And so let me introduce you to the names of these guys. We're going to talk about a Russell Ranch bedrock unit here in the Rimrock Inlier. We're going to look at the Indian Creek mappable unit, kind of a complex. Those are the two that I want to look at, Russell Ranch and Indian Creek. Okay, well, I'm not totally sure what I'm looking at. So let's break open a few more things and see if we can gather enough observation to, when we go to Bob's descriptions, we can feel like we have a reasonable thought. Instead of scrambling up there, I think I'm just going to break open some stuff down here. Now I know what no, I shouldn't do that. Let's go here. Nasty looking stuff. More veins. Greenish. Boy, I don't know what to do with this. What do I do with this? Stuff up here's kind of caught my eye. It's like I'm a 4-year-old now. It's like, oh, shiny. Let's go see what it is. Can you see this older man falling down the hill? The sun is hitting this surface at least for me, I don't know about for you. And it's quite smooth and shiny and almost kind of, yeah, it's very waxy, almost like the slick inside scene that we had up at Ingalls. Well, before we go, I'm kind of down here in the talus, and there is rather it's not rare to have these quartz veins shooting through. So that'll be a key for us. If Bob starts describing some of the units and talks about one of them being shot full of quartz veins, then that'll be a clue that we're looking at the right unit that he's describing. Is this Russell Ranch? That's my question. Is this the Russell Ranch mappable unit? Is that the one I broke open? I can't resist. This one is so, yeah. Are these pillows? Is that crazy to even say? Why are they so mound-like? Why is that the scene with much of this? You could almost talk yourself into this as Mesozoic pillow basalt. I don't know if that's a totally stupid thing to say or not. Is this what it looks like when you take a pillow basalt and you jack up the temperatures and pressures to the point where it can't stay basalt anymore, but it retains its glassy look and it retains its pillow look? Now I'm getting interested. Is that really the story? I mean, let me pull back out for a second. Wasn't that the first thought that at least I had, maybe you had too? That if it wasn't for this kind of greenish look, and if it wasn't for such a, oh man, maybe this is. If you're losing track of why I'm getting slightly excited, I'm wondering if this is a metamorphosed pillow basalt scene. I know it's Mesozoic, I know it's part of this Inlier, blah, blah, blah. I know there's an oceanic story. That's not dumb. It's entirely dumb that I'm standing here in late August of 2020 and thinking I'm looking at Mesozoic pillows. But I'm not afraid to look dumb. Let's read, see how dumb that really is. The Mesozoic Rimrock Inlier lies between the North Cascades, Blue, and Klamath Mountains, and thus has significant implications for the basement of the Columbia Embayment. I've got questions about the Columbia Embayment, that's for sure. The Russell Ranch Complex, which is my leading thought for what we're looking at right now. How's the focus here? Is a tectonic melange consisting mainly of arkose and mudstones with subordinate chert conglomerate pillowed greenstone, hello, and minor green tuff. Deposition may have occurred in an inner fan or the inner part of a mid-fan, in other words, submarine. Then he goes on to talk about potential, oh my God, These are Mesozoic pillows. Sweet. Okay, I think I need to say two things. Number one, I would never edit out a bunch of stuff that makes me look stupid. Look, I just want to be straight with you. I'm not afraid of looking like a dumbass. Sorry, Patrick. I'm not. I mean, anytime you're out with any geologists who are seasoned pros, they're asking rather basic questions. So I have no problem just kind of thinking out loud like I just did in front of this outcrop. That is to say, I didn't read ahead. I didn't, fake the whole thing and go, I wonder if these are pillows. And then it went and read, and it turns out they are pillowed greenstones, which I'd never heard of till right now. So that's comment number one. The second comment is, if you're unfamiliar with what a pillow is, now that we realize that these are pillows, I'm used to teaching about pillow basalt, which is 15 million years old, from the Columbia River basalts, the German chocolate cake. And the story there is that we have lavas, basaltic lavas, that are flowing into lake water. And I'm doing this with my hands because the lava is flowing into the water, and as the lava, the hot Hawaiian-like lava is flowing into the water, it's splitting into these fingers. And we know that's the process because we've seen what happens to Kilauea lava flows going into the Pacific Ocean in Hawaii. Okay? So those are pillow basalts. And so if you have these kind of mounded pillow-like structures that are basalt, you can say quite confidently that those pillow basalts are telling you that water was present. Again, 15 million years ago, it's a bunch of freshwater lakes here in central Washington. Well, major news for me and maybe for you is that you can go to the Rimrock Inlier, look at a portion of the Mesozoic basement in the earliest days of assembling Washington, and you can find pillows, but they don't look like basalt. They don't look like the basalts that are 15 million years old. These are pillows that are more than 140 million years old. And it's not basalt anymore because of the collision and the high temperatures and pressures that took those original pillow basalts and transformed them into greenstone. Greenstone is a metamorphic rock that used to be basalt. So, I'm excited. Thanks for listening. Okay, let's do a little bit of reading quick. Good stuff here from the paper, San Jose State, and the Russell Ranch complex, which I'm now confident we were looking at with those pillowed greenstones. I'm not flipping you off. The Russell Ranch complex, chaotically deformed, weakly metamorphosed, supracrustal rocks. Bob refers to these as a complex rather than a formation because many contacts are faults and the rocks of the type section are not a single stratigraphic sequence. He's got all sorts of breakdowns of the amazing group of rocks that are in this Russell Ranch unit, including a Chert Tuff unit, which we may or may not see today. He's got all sorts of ways to quantify what's in here. But let's look at what he writes for what we just saw with the greenstones. They occurred as pods within the clastic and chuff. So the greenstones occur as pods within the clastic and Chert Tuff units.
The greenstones are generally faulted against clastic rocks. The greenstones are typically veined, like the quartz veins we saw, slicken-sided, we saw some of that, tectonically brecciated, which simply means that it's been shattered due to plate tectonic forces. Most of the greenstone pods consist of pillowed or massive flows which lack amygdules and locally are interbedded with sandstones and mudstones. The eastern greenstone belt consists almost entirely of pillowed flows, amygdaloidal. I forget what that means. Amygdaloidal. Okay. This is another look at Bob's map from 1989 that I just colored with some colored pencils this morning. So everything here in blue is that Russell Ranch unit, a clastic unit, and then I chose a little darker blue for the Chert Tuff unit, which we may or may not see. I'm starting to wonder if we'll see the Indian Creek today. This is a big area. But notice how much Russell Ranch we have. Again, White Pass all the way down to Rimrock Lake, all the way north of Burnt Mountain, we're into the Rattlesnake Creek drainage area. And we are now climbing up on Pine Gridge Ras Road. This is all white, by the way, because this is where the Titan andesite lava flow, which is less than 3 million years, is flowing towards the Fred Meyer in Yakima. So that's not helping us today. The Titan andesite lava, which came out of the Goat Rocks volcano, that's covering up a bunch more of this stuff. But even though we can peek down in, we can see how Bob has mapped a bunch of this stuff. Again, the brown is Indian Creek, the blue is Russell Ranch. Yeah, and then the greenstone stuff. All right. And in cross-section, you can see that things are deformed. Let's go out and I'm not going to look at anything in particular here, but it's a nice, I stopped here mainly for the view. So instead of just reading this paper in an office somewhere, let's check this out. Pretty spot. Looks like we got some outcrop here. Come on. I'm not giving up. All right. Fresh stuff. Sparkly fine minerals. Dark gray, fresh, brown, weathered.
I've had enough. I guess still part of the Russell Ranch, but underwhelmed currently.
Okay, pretty sure we are now a little further along the southern edge of Rimrock Lake. That little white thing is another place where the Titan andesite, just like this, is covering things up. But I've positioned ourselves so that I'm quite sure that we are now in the dark blue. And the dark blue is what Bob Miller calls the Russell Ranch Chert Tuff unit. I think it's right over there. Let's go look at it. But before we do, a Chert Tuff unit that contains distinctive green tuffs and red shales and abundant cherts in addition to sandstones, mudstones, greenstones, similar to those of the clastic unit. Radiolaria have been identified from cherts in the 8 localities by Bloom, who did the work back in the 1950s, I think. Let's hang on. More on the Chert Tuff unit. Abundance of chert. Radiolarian chert makes up almost 15% of the unit. Massive to thickly bedded to thinly ribbon. So this is like ribbon chert from the ocean floor. Red shales are generally less than 15 meters in thickness. All right, let's go see if it actually looks like that. We're looking, it's like Christmas now. We're looking for red and green. Okay. Chert and Tuff. Well, it doesn't look like the pillows, does it? Good light. Thickly bedded stuff here. And you're like, bang, break something open. Well, this is interesting. I don't know, are these what chert beds look like from the Mesozoic? I guess so. With the tuffs that I'm used to seeing, I must admit I'm looking at things that are far younger and more tuff-like. Like Smith Rock, for instance. That was a tuff we were looking at. Oh my God. Stuff is beaten up. I don't know. I guess this is chert. I mean, you go to the San Juan Islands, Darrell Cowan country, and you see ribbon cherts that are truly beautiful, like ribbon candy. This verges on that.
Not quite that spectacular, but I don't know. Let's keep looking. It's definitely a tectonite, meaning it definitely has been, involved in a lot of drama here. This is not a simple unit. You can't just follow layers nice and easily across the outcrop like you can in quieter places tectonically and also younger places. All right. And we're getting kind of cherty here, to my eye. Yeah. To me, this is a bit more obvious that we're looking at ribbon chert that has lots of radiolaria fossils within them from the age of the Mesozoic. Yeah, this is not bad. I like this area right in here. Come in closer for you. So my most basic message, without knowing a whole lot more, is that we're looking at layers of silica that were deposited in the dark on the floor of the Pacific Ocean, perhaps off the coast of Mexico or off the coast of Southern California. So it not only gets crammed down to the edge of North America, but it also gets shifted north more than 1,000 miles. Yeah. This is the best spot, I think, to convince ourselves we are in the Chert unit of the Russell Ranch mappable unit or formation. Butterflies. Okay, before we go, I want to make sure we get a chance to look at the Indian Creek unit. And so we've left the southern shore of Rimrock, and I've swung in past the little private airport, and have worked my way about right here. So I'm on this little peninsula, basically, between Lonesome Cove and the rest of Rimrock Lake. And surprisingly to me, this whole little peninsula, according to Bob's map from 1989, is brown. And brown is the Indian Creek Isotropic unit. Now he also has a foliated unit and kind of another undifferentiated unit, but let's just look at the isotropic unit. And what does Bob tell us about the Indian Creek complex? The plutonic and metaplutonic Indian Creek complex. So in other words, this is mostly igneous and slightly metamorphosed igneous. Crops out in different discontinuous belts. Tonolitic rocks, meaning granite-like rocks, are most abundant, but there's also gabbro, diorite, and trondhjemite in significant amounts. Amphibolites are subordinate, in other words, not as many. And what does he tell us about the isotropic unit? Several intrusive faces in the isotropic unit are well displayed in the canyon of Indian Creek. Well, we're not heading up there. I'm getting hungry. Gabbro and diorites are intruded by voluminous tonolites, and there's even pegmatites. Chris Mattins's dad
Jim Mattinson wrote to Bob about some correlative units. Actually, before I leave this page, let me point this out and then we'll go look at the rocks. This is also in Bob's paper. And yes, we are at the Rimrock Lake Inlier. I think I've just been calling it the Rimrock Inlier, the Rimrock Lake Inlier. There's the other inliers that we have now visited. Ingalls, Hicks Butte, Menashtesh, remember? We've been at all those. And notice that the Straight Creek Fault, which is a fault that showed up after Baja BC did its thing, has offset western Washington northward compared to eastern Washington by up to 100 miles, between 60 and 100 miles, depending on who you talk to. But our topic today is far enough west that, to me, there's a fundamental question. Does the Straight Creek Fault continue underneath younger stuff just to the east of here? Or does the Straight Creek Fault truly stop here and merge into something called the Olympic Wallowa lineament? Nobody seems to have a good feel for the owl, the Olympic Wallowa lineament. And so we'll leave that alone for now, but tied to that is, do we continue the Straight Creek Fault to the south? Just for fun, if we do continue the Straight Creek Fault underneath the cover through here, then that means this stuff does not match this stuff underneath cover, and instead this stuff should be almost 100 miles down in Oregon. Put that in your pipe and smoke it. All right, leave the papers, walk down to this place that looks like it might have some outcrop. I mean, there's some here, but I think we need better than that. All right. So, I'm hoping that we can find some outcrop. Oh. Cozy. Good place for a campfire. Oh, the nice cooling breeze is coming off of Rimrock Lake. I like it. All right, pretty steep here, which must mean that we have some outcrop. Well, I don't know if it's the most attractive looking bedrock. Good God. It's not Mount Stewart granite, let's put it that way. God, this stuff is rotten. Underwhelmed. So these are magmas of different compositions that I got to deal with bedrock now. Who knows what was brought in by the boating community, and there may be some stray Titan andesite blocks that kind of got rifted in here. It kind of reminds me of being down at San Juan Islands when we filmed a little program there. Same aged rock, same complicated look. All right, this is a little better.
How do I get out of my own shadow here? All right, this stuff looks a little better. There's some fresh quartz in here. Another little quartz vein. What does this stuff look like? Fine grained nothingness. Well, I'll say it's complicated looking. Yeah, this is not bad. So I'm pretty confident we're looking at complicated magmas and magmas that have been turned to igneous rocks and then some that have been turned to metamorphic equivalents. The Indian Rock, God dang, the Indian Creek Complex, is that what it was called? Look at how fractured, look at how shot full of veins it is. And I can't even really get a good sample of the plutonic rock to study. Let's go over on this point. Maybe we'll have a little better luck. It's just rotten. It's like a plutonic rock that's like a major disappointment to its parents. There was such promise once upon a time, but what happened? And I got to use the point end of my hammer just because this stuff is blech. I don't know, pretty blue water, I guess. Jeez. Can't even really get a fresh surface on this. Oh, gee, come on. You're wasting my time. I mean, just the most fresh stuff that you can see. Oh, this one might have something for us. That's the best we can do, I think. Very difficult to see much.
But we have specialists like Bob Miller who knows how to work with rocks like these and salvage information. To most of us, this looks like junky rock that's not going to tell us anything. That's why we have experts, ladies and gentlemen. Well, what do you think? That's probably enough for today. A few rocks to look at, a few concepts from this southernmost window into the Mesozoic within Washington. If we go south of here, we got to go all the way down to the Klamaths in southern Oregon and northern California, the Siskiyous, to see a continuation of these Mesozoic rocks. Thanks for joining us. I love you and goodbye.